Hi, I'm Paul Blanton, President of EEC, and today we're going to talk a little bit about how active and passive vibration isolation systems work together to provide a total vibration isolation solution for your instrument. So to start off, we're going to discuss how we look at the world in terms of what we call low frequency and high frequency vibration. So low frequency vibration is kind of anything under like typically what we would say like 15 to 20 hertz, and it corresponds with excitations of soil resonances, structural resonances, or building resonances at your facility. And kind of the way it works is whenever there's an impulse, say construction or a truck driving over a speed bump, that impulse excites the soil resonance or structural resonance and causes the vibration between, that correlates with that resonance to elevate, which is problematic for instruments, sensitive instruments. So now that we've discussed what we consider low frequency vibration, now we're going to talk a little bit about what we consider high frequency vibration. So we consider basically anything above about 15-20 hertz to be what we call high frequency vibration. And it almost always corresponds with a very specific vibration frequency that correlates with a piece of mechanical equipment or vibrating equipment in the environment. So here in the US, we operate off 60 hertz motors, and so we often see, almost always see, vibration just below 60 hertz because of this 60 hertz drive frequency. And so the reason it's just below 60 hertz is because of motor slip, but it's a very common frequency and is almost always apparent in the data. If there's any type of reduction gears or gearing or on a piece of equipment, we'll see the vibration frequency to be different, typically lower, but the end result is a very specific vibration peak that's very stable over time. Transformers are a little bit different. They buzz at 120 hertz. That's a common source we see in the data. And of course you have variable frequency drives, or VFDs. Those drive motors at variable frequencies, and so although the frequencies change over time, at any specific time it's at a very distinct frequency based off of this specific frequency that motor's spinning at the time the measurement's taken. So now that we've talked a little bit about both low frequency and high frequency vibration and the differences between the two, we're going to talk about active and passive vibration isolation systems and how they're different and how they address the different types of vibration we discussed earlier. So we're going to start off by talking about passive vibration isolation systems, because that's what you typically find on board electron microscopes or other types of precision instrumentation. So a passive vibration isolation system always has a natural frequency where vibration is amplified before it is attenuated. So on most the instruments that we work on, that natural frequency is kind of in the 2 to 10 hertz range, meaning that vibration in that range is amplified before the vibration attenuation occurs. These onboard passive isolation systems work great because they attenuate vibration that you see from mechanical equipment and vibrating sources in the environment. So the 60 hertz motors that you see, the VFDs, transformers, etc., those are effectively mitigated by the onboard passive vibration isolation systems on these instruments. But the problem is, as you can probably tell, is the natural frequency amplifies the low frequency vibration sources we discussed earlier. So onboard passive vibration isolation systems work well for the higher frequencies, but they are susceptible to low frequency vibration like we just discussed. So that's where the active vibration isolation systems come in. So active vibration isolation systems, a good one, will start performing kind of at the 0.5 hertz range and be effective through the low frequency range and beyond. And so this is important for two reasons. One, it helps mitigate the excitation of soil resonances and structural resonances we talked about earlier. So those things that are excited because of construction or traffic or subways, etc. And then two, it is effective at mitigating vibration at the very frequency range, the natural frequency, that the passive isolation systems are particularly susceptible. And so, that is why these systems are great when they're paired together. So if you work with VEC and you get one of our active vibration isolation systems, we're going to pair it seamlessly with your onboard passive vibration isolation system, giving you outstanding vibration isolation performance and protection all the way from 0.5 hertz to 100 hertz and well beyond. So we'd love to talk to you about your situation and your specific project. If you have any questions, please feel free to reach out to us. We're at www.vibeng.com. Give us a call, send us an email, and we'd be happy to talk to you.